I think everybody is just tired because it's just how quickly everything is changing. Some would say the IDE is dead. Now that I've moved on to agents writing, multiple agents running, because they're capable of doing more for longer. What you're doing as an engineer is actually different work. And that's a really important shift that I don't think a lot of people have made yet. I do think in a year or two, what we think of engineering is not writing code, but literally like, I'm building the factory system. I'm not working on the factory line.
You're listening to We Built What, the podcast for engineering leaders building in the agentic era. I'm Emma Webb, your host from Augment Code, and today I'm here with my colleague and my pal, Chris Kelly, our product lead. Chris, thanks for joining.
Thanks for having me.
Oh my goodness, it's such a joy that you're here with us on this show.
Yeah, it's a gorgeous day today. Happy to be here.
So, Chris, you have had a front row seat to all of these major developments in software engineering from your time at GitHub and New Relic and Salesforce and Fire Hydrant. And so I think one of the things that I'm really wondering about is how do we contextualize this AI moment as compared to all the other things that you've seen throughout your career?
Yeah, I think software's always been changing, right? Like it really has been evolving, right? Over the last 50 years, it's gone through major leaps and bounds. You know, I've seen everything from the internet being born when I was first getting out of high school and saw how that changed everything. We saw the cloud revolution sort of in the early 2010s. Now we're AI. The big difference, one, is speed. Like, I think everybody in this space is tired because it's just how quickly everything is changing. But also, like, it's not just making a faster horse anymore. Like, a lot of the other things we kept on just kind of getting faster at things, everything from going from low-level languages to high-level languages. That's still doing normal programming, but just kind of at a higher abstraction level and kind of being able to do that faster. This actually, I feel like, is a change in what we're doing. The actual work is changing. We used to generate more code. That was early AI days. But now I think in this like new shift, as agents have really started to take hold, what you're doing as an engineer is actually different work. And that's a really important shift that I don't think a lot of people have made yet. And so that's what I see is the core difference is like, I do think in a year or two, what we think of engineering is not writing code, but literally like, I'm building the factory system. I'm not working on the factory line. And so that's a whole different thing to think about.
Dive a little more into that. Can you give me more specific examples of kind of like the before and after?
Yeah, let's take an old analogy of we took low-level languages, let's say assembly to C. Assembly to C was a huge shift, right? We went from punch cards to assembly, and that's a whole big shift, right? And so that's just kind of doing the work faster, right? Like I can write the amount of code I'd have to write in assembly, I can do a lot more in C. How much code I had to write in C was much less code or more leveraged code in Ruby or Python or pick a C-based language. And so that's just as me able to do more faster. What's shifting here is we're not really trying to write more code. I'm trying to get the LLMs to produce code the way I want it to be produced. I'm not thinking about the end software. I'm thinking about how that software ends up getting assembled because LLMs aren't perfect. Like anyone that's like, oh, LLMs, software's a solved problem. It is if you are engineering the system that produces the software. And the goal of software engineering now, to me, it feels like we're trying to make sure the LM produces the kind of code we want and less about like, make this button do this thing or make this software have this behavior. You're working on making sure the agent has the right context, the right structure, so it can build the software for you. So then you can say, make me a button and not think about, did it make the button correctly, right? Because that's, I think, the difference. That's the real shift is we used to just produce more code. Now we're producing code to produce something different. So in that factory analogy, we used to work on a factory line, we're making widgets. Maybe we were making widgets by hand, we're hand carving with tools and then we got a machine and, a lathe and things like that. We just did the same exact thing, just faster. Now I'm the engineer that's making the lathe, right? Like I'm making the lathe system itself so that the agent can then make that widget.
You're talking about how much the role has changed. And my question for you is like, the role is very different. Is it less fun, more fun, a different kind of fun? Because some of our joy that we get from our work is like, I like doing this type of task.
Yeah. So I come from the software craftsman, parts of the software industry that like cared about software craft, everything from object-oriented design and really thinking about the code we're building. So yeah, there's definitely a loss there. And that does feel like it's a shift, and that's hard to let go of. So it depends on who you are. Like if you really do love the craft of writing the perfect system, then you're going to feel some loss. And I empathize with that. I've always enjoyed that experience, but it's never been the thing that like got me excited about writing software. Writing software is like, I wanted to build a thing. I wanted to make a system. I think, in some other life, I would have been an architect. For me, it's the building concept that really resonates. And so this doesn't change that for me, but for somebody that is truly a craftsman, right? Like a master woodworker, right? Yeah. If I'm no longer doing that woodwork on that building and, the joinery, then yeah, that's going to feel worse. And I don't have a good answer for how to just make that transition to like, oh, great. You don't have to worry about the joinery anymore. You have to worry about a different thing. I think it's just going to take people some time to get past that. There's always going to be a place for the craft of writing software. That hasn't actually changed. I think that's the misconception though. It's like, it's not vibe coding. There's a bunch of spaghetti in this code base that I don't care about. If I've ever sat down to write a piece of code and I didn't really have a mental model of what I was going to write, the thing that came out of the end of it was never good in the first place. Whether an LLM was helping me or I was handwriting it, it was still kind of garbage. So I have to know what the outcome is supposed to look like in the first place in order to get the agents to produce that outcome. That doesn't change.
Is the goal of building the software factory to create code output that is indistinguishable from what a software craftsperson would produce? Is that possible?
I think it's possible. I don't think we have figured it out yet. So I think there's a wide gap there. The reason I think there's so much pushback is because it does take a lot of work to get an LLM to produce the kind of code that you want to produce. We've always written software differently. If you were writing a PR and I was writing a PR for the same functionality, we would end up with different results.
You should choose someone different, not me.
But like, we would definitely, we would absolutely end up with different results. But like our coworkers have always produced different code. If that's the case, then you have to start to get comfortable with, well, it doesn't have to write code like me exactly, but it does have to write code in the systems in which I believe with the principles I want in order to make good software that is reasonable. What's really important, I think, that gets overlooked is good software design is better for agents to work in anyway. So the more spaghetti code you end up with, the more the agents get confused about what it's supposed to be doing, and therefore it just stops working altogether. So you're actually doing yourself a disservice if you're not thinking about the code quality and writing code the way it should be written, because inevitably that piece of software the agent will just grind to a halt on what it's capable of doing.
So you've been talking about how the role of engineering has shifted from kind of being on the factory line to building the factory. And you are yourself building a software factory right now with this new product that we have called Cosmos. Can you tell me a little bit about the inspiration behind, like, why are we doing this? Chris, we have agents. Just let me throw some agents at it. Isn't that a strategy?
That is one strategy. So the inspiration, it's been about a year, I guess, at this point in time, where I was thinking about sort of these closed loops of software development. The company I worked for prior was in incident response, and we thought a lot about what happens after production codes get to production and how do we get those learnings back into the system itself so you don't end up with those production systems. So you abstract that a little bit and you think about like, well, isn't all software just a big software loop? And if agents can reason about each of the themes between our systems, right, from writing code to a PR to a build system to production into an incident, and if I can put something that has reasoning power at each of those themes, then like I can start to get this closed loop of software development. And that really started the idea of like, well, why couldn't we do that? Why wouldn't an exception that's being thrown or an incident that's being thrown in production automatically just open a ticket? And if I've opened a ticket, then why can't an agent try to tackle that ticket? And if an agent can tackle it, it can review it. If it can review it, it can put it out to a canary to deploy it. If all the monitors are working there, then it should just continue to roll it out to 100% of my production code. And so then you're like, oh, well, why wouldn't we do that? We're already doing it now, just manually. When you start to think about the shift that ended up happening, let's say from June to December of last year, was the reasoning capabilities of agents really, really changed, right? We were just doing relatively code generation behaviors in, say, June of last year, but come November, December, as we say, the opus moments, that changed the reasoning capability of the model. And so once the model can reason, then you feel a lot more comfortable putting it into those seams between systems. This isn't actually just new. It's just kind of fulfilling the promise of those sort of original efforts.
Okay, so Chris, you're building what we've been describing as kind of a new operating system for agentic software development, a product we call Cosmos. Are there any core principles you're trying to keep in mind? I know you're a man of principles.
I try to be.
You
Yeah.
are.
Yeah.
What are the ones that, like, kind of as you're guiding the direction of this platform, of this product, what are you thinking about? What are you like, we want it to do this, we want it to do this, or it should always, do you have any of these kind of like mantras, mandates, principles you're keeping in mind?
Yeah, it's more, I would say maybe not principles yet, as we kind of, this stuff is moving so quickly, but we do know that models will get better. And so we're always building sort of a little, to use another sports metaphor, we're like leaning a little over our skis. So we're going to say it's going to do more than it can, and we're going to design it to do more than it can, even though it's going to maybe do that 50% right. But in 6 months, that's going to jump automatically to 80 or 90 or 100% right. So like that, keeping that in mind when you're building the product means you're always thinking ahead versus like being late. And so that's, I think, probably the number one aspect. The other one is that agents can reason, and we want to let the agents lead. So I think the previous generation of AI, let's say up through late last year, was, oh, I send a prompt, it generates me some code. I send another prompt, it generates me code. I keep just repeating that. Again, that's a little bit of that faster horse analogy where, well, I was just actually typing the code. Now I'm having it generate me the code. One of the core principles here is like, we actually want the agents to be making a bunch of the decisions, be kind of monitoring the system, keeping track of all the things that it should be working, and going from an agent first principle that's the core driver is really a different psychology. And so you just can feed the agents a bunch of inputs over time, right? Like, so bug reports, feedback, product prioritization, and then have a system, the agent can be like, well, let me prioritize this work and create some tickets for it, and then have the agents go complete that work, verify that work. And so then the agent's doing the decision making, because you've given it the principles of how to do the decision making. And when it doesn't make the right decision, your job is then to teach it how to make the right decision in the future. And then lastly, we want everything in the system to be managed by agent. Really, the agent as the interface, it has on automation capabilities. If I want to, review the Slack channel every Monday morning from our feedback system and give me a report of the most reported issues during that week, then I can just tell an agent exactly that. And that's kind of an amazing moment where you can just like, oh, I just tell the agent to go and make me an automation of some kind. And that suddenly I just do that over and over and over again. And I get this like fleet of agents doing work, and that I'm training them how to do the job better. For me, that doesn't feel threatening. I think there's always going to be an opportunity to teach software how to do software better.
You mentioned something that I was really interested in. One of the core principles of how you're building Cosmos is that we have this core understanding that models are going to continue to advance in capability. And so we're not going to tie any major kind of architecture or product decisions to something that models can do today that they can't do tomorrow. Can you give me an example of like how we've kept it flexible so that to kind of, I guess, account for this acceleration in model capability that we know is coming?
Yeah, so different models have different qualities. They're good at different things. And so the first thing we do is make sure that we can utilize every model from any frontier lab to do different tasks. So I really like GPT 5.5 for code review. We find that it does an excellent job doing sort of a deep analysis of code versus we traditionally use like Opus for the code writing. And so we can leverage the strengths of those models by having this agnostic approach. So then you pick the right agent for the right job. And now when you're starting to automate things, you also like Haiku is perfectly great for doing some small tasks that, don't need high reasoning models. And so then you can also help control costs, because I'm assuming every CTO in the world is like watching their budgets get blown out by AI token maxing. And so, we want to make sure that's a flexible option for us. We don't know, just like the foundation labs don't also know like what exactly is going to emerge out of the next round. And so we have to keep the software flexible, what it can do, knowing that the agent is going to be able to like figure it out, that agent first principle versus like building deterministic software. We could have just built a webhook to write runs a script system. We decided not to do that. We want the agent to even manage its own subscriptions to different events and whatnot, rather than building a traditional, if then that, but with some AI sprinkled in. That flexibility allows us to capture whatever new capabilities the models come along. That's been tough as someone that's spent a career building deterministic software, right? Like, I want software to run in production the same way every single time. Getting over that has been a challenge over the last couple of years.
Ask you about that. I mean, just going from the if this then that to a little more woo, right?
Yeah.
Like how do you get over that mental shift? And I guess the answer, if I'm flipping myself to your side, is probably building all of the checks and balances, all the ways that you monitor and observe. What's the answer?
Yeah, for me, it's having the guardrails. Again, we've always had guardrails in the way we build software, right? We have test suites, we have linting systems, we have alerting systems. We've always built these guardrails into software in order to not make mistakes. Some people will try to have the agent do one big task all at once. And the problem is, in non-deterministic systems, every chance that agent has to possibly, go left or right, it could go left or right. But you put too many of those together without a guardrail of like a verification, then you might actually end up making a U-turn eventually. And so I design my systems, the agents I build, to kind of have a verification system after it's done its tasks, verify, hand off to another one, verify, and then I get a much straighter line. It's not perfect by any means. It's non-deterministic, so it's not going to be, but how can you help the agents correct themselves? And so that's the difference that we've seen.
So, Chris, one of the things that's interesting about Cosmos, or maybe not interesting, depends how closely you're following the space, but where's the IDE in Cosmos?
Well, I think some would say the IDE is dead, and I would probably say the IDE is not a surface that serves the purpose we need it anymore. But IDE was great when I was handwriting code. It was even probably great when the agent was just generating code, just at a faster rate, but now that I've moved on to, I need agents writing, multiple agents running, because they're capable of doing more for longer. So I have to have multiple going in order to feel like I'm doing anything. So that juggling becomes challenging in an IDE. It's not really built for that. I mean, you can see even in some of the IDEs, they're trying to flip the UX to be like agent first versus like file system first and file editor first. That's a lot of legacy inertia to get past. And so maybe just like let it go and think about what the new interfaces are going to be. Do an agent first interface to begin with. So there's that problem of just being able to juggle enough work simultaneously. But I think the bigger problem with the IDE is that a lot of the work doesn't even start with me prompting anything. If an agent is possibly running, a weekly report of what are the most, important pieces of feedback we've received, and it's automatically starting a session, then where does the IDE fit in that system, right? The agent decided what to build. It started building it. It verified the build. It deployed it to a preview somewhere that I can check. So at no point in time did I actually need an IDE in order to interface with this change. And so the IDE just kind of gets obsoleted because most of the work doesn't even start there. So the Cosmos team, much of Augment ends up writing not in IDEs anymore. I write in what is a web browser. It's an agent interface. I'm able to look at diffs and kind of do the work that I need to do when that's an important thing. But for the most part, that the work is kind of being handled and started all and closed all by an agent system in itself. And I'm not writing code for those agent systems. So, an editor doesn't solve that problem either. So yeah, editors just aren't really that relevant anymore. That's going to be a hard thing for a lot of people to let go of. We spent years arguing about light modes and dark modes and, tabs and spaces and all these things, and all of that can go away. So yeah, we got to let go of some of those history.
Another thing, as we are talking about this kind of move from being on the software line, building the widgets on the software factory line, to building the software factory, is that we're in this kind of interesting moment where teams that have adopted AI have adopted it even within one organization, largely very unevenly. So you might, on our token maxing leaderboards, we've got Chris who's burning 500,000 tokens a month and Emma who's burning like 5. And so just that uneven adoption on teams where because of that, we're not necessarily seeing like huge productivity gains or huge business impact because, well, if Chris is doing so much but Emma's not, well, the system has not evolved to catch up. Tell me a little bit about like that team aspect of Cosmos and how you're thinking about that part, because I think it's very interesting to me to think about. It's okay, it's not just enough that I have it's this system, it's how do I get the whole organization kind of on the same playing field? Is that the right way to think about it? Or
Yeah.
how do you think about it?
Yeah. So I think there are two things there. There's one, the system. So I think a lot of organizations have thought like, oh, we're using AI, and they've adopted, say, a CLI. Like maybe they've even gone all in on CLI tools like Augie, or others. There's plenty of others out there that like, oh, look, we're using CLIs to generate code with agents, and that's great. But again, that's a little of the faster horse analogy, where that's not really capitalizing on what an AI native system would look like, what an AI native engineering organization would look like. That's just, I can produce code faster with CodeGen. The difference is like, how do you engineer the entire system to be AI native? And so that means not just the code production side, but the code review side and the deployment systems and the alert responses. Organizations traditionally haven't done that entire, like thought through the system that needs to be a new SDLC. And rather than like, oh, my team is all using Augie or Claude Code or Codex, like they're just, they think that's what adopting AI looks like, and it hasn't transformed the entire system. So there's that aspect of you have to think through the whole system. The other one is how do you level the playing field across an organization? And this is something engineering organizations have always done, where not everyone adopts the tools at the same rate. We have a very strong culture of open source and sort of sharing and collaboration. And so by building tools like Cosmos with teams in mind, it's purpose built for software engineering teams, so that if I've developed a great solution to a thing, I can share that with the team and put that into production and have it run. That's the same behavior we've always done, where I figured out a cool solution for a build system problem, and I wrote a script and I ran it for myself for a little while, and then I made sure it worked, and then once it worked, I'm like, hey, we should adopt this tool or use this, turn this script into a server. That behavior is no different, and so we want to make sure we enable that, the sort of organizational level adoption, so that someone that is maybe just joining an org. Here you get all of the AI nativeness for free by just joining and starting to use the tools that we've already put in place. And so we want to make sure that the agents you can develop are there, the secrets you need to share are already there, all the MCP servers and tools you need access to are already there. And so one person can set it up, and then the entire organization kind of automatically levels up. Those two things together change how an engineering organization has to work. You can't do either in isolation.
It's almost like to really maybe push your faster horse analogy to the limit. It's like if you have a faster horse, you still have to learn how to ride a horse, or you could just get in my car.
Yes, we can keep having a faster and faster horse, but really what we want is to be driving in a car, right? We still want to go fast, but how we go fast is going to have to change. It's not just finding faster horses.
I think something maybe you have been thinking about this whole time, but has just occurred to me, shocking, is I think I until this moment did not realize how difficult the job of an engineering leader is right now, because it's not just about how do I accomplish the goals of my business, but I actually have to rethink how I do everything kind of from soup to nuts, which sounds not the most delightful.
Yeah.
Like that's,
Yeah.
oh my gosh.
It's organizational change, it's technical change, and also like keep the lights on with your business and serve your customers and do all the things you have to do. You're doing that all at the same time, and that's excruciatingly hard. So I think community is going to be the way to solve that, where we're sharing best practices, and we're going to dinners and going to conferences and learning from one another. I'm glad we have a culture of that already. A bunch of engineering leaders have gone through this in the past. And so we're going to do it again, and hopefully we can share that knowledge and get through it. But that is like, I think the hardest thing is sometimes we do technical changes. Sometimes we do organizational changes. Thinking about how you architect software has to be different. How you think about building teams has to be different. This is both of those things kind of simultaneously, while also trying to help your organization with empathy, your engineers with empathy of like, you're kind of losing, some of them at least are losing something they love and are having a hard time with that. So it's a lot for an engineering leader today.
Thanks for coming, Chris.
Yeah. Well, thanks for having me.
You've been listening to We Built What. If you like what you heard today, please like and subscribe, share with some other humans or some agents. If there's someone you think we should talk to, let us know on LinkedIn or X.